Hello, this is Dr. Mears, and today we're going to learn about rational functions of the forms y equals k over x plus d plus c and y equals ax plus b all over cx plus d. So first, let's look at the first one. Y equals the quantity of k over x plus d plus c. K, c, and d are all constants, so they're numbers. We're going to have numbers in here. Horizontal and vertical asymptotes. That's where they don't cross. Remember that line that they get to really closely, but they never cross. So the first one is going to be the horizontal, which is going to be side to side, and that's going to be y equals c. So whatever this value of c is, whether it's positive or negative, we're going to have it here. The vertical asymptote, which is up and down, is going to be x equals the opposite of the d value right here. So let's see what this looks like in an example. Number one, sketch the function y equals 1 divided by x minus 2. Show any asymptotes except if it's on the axes as dotted lines. I actually did this for you. I thought it'd be nice to see that we have the first asymptote as the x-axis here. And it's not shown as a dotted line because it's already a line. So it is an asymptote. This curve will never pass the x-axis. This curve will never pass the x-axis. And then we have another asymptote, another number where it's not going to, another line where it's not going to pass. And that's at 2. So it's never going to pass this imaginary dotted line. It will never pass here, and it will never pass here. It'll try to get as close as possible, but never pass it, which is a definition of an asymptote, and we're going to start learning about limits. So this will bring us into limits one day in the near future. So I sketched that for you. Show any asymptotes, the dotted line right here through the value of 2, and of course the x-axis. Number 2, write down the equations of the horizontal and vertical asymptotes. So let's do the horizontal asymptote. So remember, the horizontal asymptote is, we're going to set it up as y equals. Now we need the c value. So let's go back. Let's write this out. Y equals 1 over x minus 2. Now notice there's no number here being added or subtracted. And if there's no number, we're going to put plus 0. Then I'm going to write down my c values and my d values. So let's look here. C value. C is that number being added or subtracted. Well, ours was, C value is the number being added or subtracted. So ours was 0. The d value is in the denominator. D value is in the denominator. D value right here is going to be minus 2. Remember, if it's a minus, you take it out and you make it that negative 2. Now that I got my C and D values, it'll be easy to find my horizontal and vertical asymptotes. So the horizontal asymptote was y equals C. C is 0, so our horizontal one is y equals 0. Our vertical asymptote is going to be x equals, and now we have the opposite. I already put that in because I need to remember that I'm doing the opposite of my d value. Now my d is going to be negative 2. So notice it's the opposite of a negative, which comes out to be positive. Now, if you could already go, if you can say, okay, it's negative, so when I do make it an asymptote, it will be positive, that's fine, and vice versa. But I just really want to show you why it turns that positive here. All right, state the domain and the range. So let's look. So the domain here is going to be all real numbers. It's going to go towards all of the positive x values. It's going to go towards all of the negative x values, but which one won't it cross? It's never going to cross this x value of 2. So our domain is going to be all reals, but x cannot equal, x can never be 2. So x cannot equal 2. Let's do our range. So remember, our range is up and down. So here we see that it's going to be going towards all the positive y values. Just move this up a little bit. And here it's going to be going towards all the negative y values. Okay, so all real numbers. Now, here is the thing. So all real numbers, but what is it? Isn't it going to pass? So it's never going to pass this y value of 0. So y cannot be equal to 0. And notice how these both match up with our horizontal asymptote. and our vertical asymptote. So our horizontal asymptote is where our range will never be able to reach, and our vertical asymptote is where a domain will never be able to reach. So just that is a hint. It will always give you a hint. Those will always line up like that. Okay, our next one. Rational functions in the form quantity ax plus b divided by the quantity cx plus d. Now, A, B, and C here are all constants, and let's go through, and I basically listed how to find everything. So this is a nice golden page to have, a little notes page, where it tells us if we pull out what our A, B, C, and D are, we're going to be able to find our horizontal asymptote, our vertical asymptote. We're going to be able to find our x and y intercepts where they cross, and our domain and our range, which we see domain all real numbers except for the vertical, all real numbers except for the horizontal, which is just what we looked at. So let's look at our examples. We have the function y equals quantity of 4x plus 1 divided by the quantity of 2x minus 6. We need to find the following: horizontal and vertical asymptote, and then we're going to be turning the page. Now notice I left some space here because what I'm going to do is I want to pull out my A, B, C, and D. So this is A, this is B, this is C, and this is D. And I want to list them. A is going to be 4, B is going to be 1, C is going to be 2, and D is going to be negative 6. Remember, if it's a minus, it's going to be negative. Now that I have all my numbers, I can use all of my formulas to substitute them in. So my horizontal asymptote right here is y equals A divided by C. So y equals, our A was 4, our C was 2. Can I divide that out? Yes. So let's write y equals 4 divided by 2 is 2. Put a little box around it because we're going to be going back to use that to tell me what y can't be for our range, right? Vertical asymptote, let's go look. Vertical, x equals negative d over c. X equals negative d over c. And I didn't write that here, a over c, if you wanted to put that in there. Okay, so x equals the opposite of d, so the opposite of negative 6 over c, which is 2. So x equals the opposite of negative 6 is 6 divided by 2. And 6 divided by 2 is going to be x equals 3. Put a box around it because that's going to help us with our domain. Okay, what do we need to find next? And I'm going to keep this paper handy because I'm sure we're going to be looking back at it. X-intercept. Okay, x-intercept. How do we find our x-intercept? Before we do that, I'm going to write down what the function was. 4x plus 1 divided by, whoops, that was not a good looking one. 4x plus 1 divided by 2x minus 6. I'm going to write down A is 4, B is 1, C is 2, and D is negative 6, just in case we need it. And get just particular here. Okay, 1. So how do we find we need x-intercept. Okay, so x-intercept is right here. Substitute 0, y equals 0. So we're going to substitute 0 for y, and we need to solve for x. Well, that makes sense, solving for x. So we need to substitute 0 in for y. 0 equals 4x plus 1 divided by 2x minus 6. Because remember, x-intercept is going to be a point. Where y is 0, we need that x number. So how to solve here? I'm going to put these in parentheses because what I can do is, because this is separated by division, I can take this whole expression and multiply it by both sides. So this is going to cancel out. What happens here? What number or any expression times 0? Yeah, it's going to give us 0. So now I'm at 4x plus 1. Will it always be the numerator? Will it always work like this? Yes. If you want to take the shortcut where you're just going to take the numerator and set it equal to 0, you can. I'm just showing you where all the numbers come from. So now it's a two-step problem. Subtract 1 from both sides. Negative 1 equals 4x. Going to come up here. Negative 1 equals 4x. Divide by 4. Divide by 4. We're doing this all year. So x equals negative 1/4. So this is not our final answer. Our final answer at the x-intercept would be this right here in point value. It crosses the x-axis at negative 1/4, 0. Y-intercept. Well, if we were substituting 0 in for y here, we're going to substitute 0 in for x, and I'm sure we're going to find y. And that's what it says on our paper as well. Y-intercept. Substitute x equals 0 and solve for y. So we have y equals, we're going to put an x in for 0, 4 times 0 plus 1 divided by 2 times 0 minus 6. So here we're going to have y equals 4 times 0 is 0 plus 1, 2 times 0 is 0 minus 6, bring it up here. Y equals 0 plus 1 is 1, 0 minus 6 is negative 6. Not the final answer, we're going to go back, negative 1, 6. Here we have negative 1 over 6. There we go. So now we have the x-intercept and the y-intercept written out in point value forms. Bells, all the bells again. Okay, next on our list here is the domain. So remember, the domain is all real numbers except for the vertical asymptote. So let's write that, all real numbers except for, and now our vertical asymptote down here was 3, except for 3. If you want to write x can equal 3, you can as well. So that was our vertical asymptote right here. Range, all real numbers except for our horizontal asymptote 2, so y cannot equal 2. Either way you want to write this, it's completely up to you. Okay, now the last one. The last one, I am bringing you back to functions and inverse functions because for my classes, our final is coming up and you're going to have to remember how to do this. So I figured I'd bring rational functions in and do a little bit of algebra work and let you kind of remember and focus on what we did about a month ago. So here we have f of x equals x minus 4 divided by 3x minus 2. We have to find the inverse function of x. So remember this little negative 1, that meant inverse. So inverse is where we're going to change this to y equals x minus 4 over 3x minus 2. It makes it easier to solve. And the first thing is we're going to switch x and y. So instead of the y, we're going to put an x. Instead of an x, we're going to put y's. Okay, that's the first step. Remember that, that's what an inverse is where we switch x and y. Number 2, we're going to solve for y. So we need to get it back in terms of y. Now you're going to bear with me here because if you're not good at solving equations, I'm going to say this summer you might want to visit Khan Academy and look at some videos of how to solve equations if you're not good. Okay, so do that because I am going to run through this. So just like the one that we did up here when we were finding the x-intercept, what we're going to do is put parentheses around this so that we can multiply it by both sides. We need to get the denominator out of there, so that's out of there. Okay, we are now at 3y minus 2 times x equals y minus 4. We need to get these parentheses out of here, so yes, we are going to multiply. So we get 3xy minus 2x equals y minus 4. Okay, what are we going to do now? Let's bring all of the y's to one side. So let's get this y over here. So minus y, that crosses out. Let's go up here. So I'm at 3xy minus 2x minus y equals negative 4. Let's get whatever's not a y over here. So we're going to bring this negative 2x over. So all we're doing is bringing the y's to one side. So plus 2x and plus 2x. That's out of there. So we have 3xy minus y equals 2x minus 4. Remember, you can't combine these because the 4 doesn't have an x. Because we have the y's on one side, notice this term has a y and this term has a y. So we can undo this. We can put it back in parenthesis form. If we take a y out of 3xy, we get 3x. If we take a y out of minus y, we get minus 1 left over. And yes, I'm hoping you see it. This is multiplication. So we're going to divide both sides, by 3x minus 1. And so our y equals, and if you wanted to change this into f of negative 1 of x, 2x minus 4 over 3x minus 1. Now, this may be a lot for some of you because you may not be strong in solving, and that's okay, but you need to take the time to learn how to solve equations to practice. Khan Academy has some good videos. Also, YouTube has some good videos as well. Or you could review this video to see each and every step and take notes on each and every step, because solving these rational functions is, when we do the inverses, is pretty much the same for each type of rational function. Okay, and our last page, yay! We're going to be real world problems. We have Chase and Dev are planning to print their sport team logo on baseball caps and sell them. They have to hire a printing machine, which costs $500, and it will cost them an additional $5 for every cap to be printed and bought and printed. Part A says develop a model which links the numbers of caps they produce with the average cost per cap then incur. Now, average means we want it per cap. So let's just model this out. We hired a printing machine. Okay, so y is going to be the total average cost. So this is average cost. Okay. First, we went and bought a printing machine. That was $500. Then, each shirt, we're going to have to add on, each shirt is 5x. Or each cap is 5x. We're dealing with hats. So each cap is 5x. Now, in order to get an average, we have to take this amount and divide by how many there are. Remember, an average is adding them up and dividing by the number that you have. That's what an average is. Average. Add them and divide by the number of items. So if we have 7 caps, we divide by 7. 8 caps, divide by 8. That's what the average is, and that's why we get a rational function. All right, use our GDC to determine how many caps must be printed and sold if they are to sell 7 caps at $7 per cap and just break even. So on your graphical display calculator, you're going to put y1 equals 500 plus 5x. y2 equals, what do we want? 7. And you might even need to do a zoom fit on this one, a 0 zoom fit, because as you notice, the x goes to 300. Now, I did this for you. If you're having trouble with this, please, if you're in my class, ask me how do I get to see the picture. We've gone over this a few times, so that's why I gave you a nice picture of it so you're not drawing it. So here is the line, y equals 7 right here. Here's the line. Here is our curve, so this is our y1. This line is y2. That's this line right here. That's y2. And we want to see where they intersect. So you're right. We have to do a second trace, and then we have to do intersect. And when we do that, we're going to see that we come out with x equals 250 and y equals 7. So this is how many they have to sell. And if you are unfamiliar with how to solve this, doing a second trace, please go back. You can watch my first video, Rational Functions Part 1. This has been Rational Functions Part 2. Hope it helped.